Welcome to the Watershed Learning Network. In this module, we will be defining water infrastructure. Infrastructure is the system of public works, also publicly owned utilities, of a country, state, or region. It is also the resources, such as personnel, buildings, or equipment, required for an activity. Examples of infrastructure include streets and highways, sewers, water supply systems, electricity supply systems, and natural or other types of gas supply systems, and communication systems. Communities across the United States are facing challenges associated with aging and obsolete infrastructure. To obtain more information about the quality and quantity of infrastructure in the U.S., you may want to visit the webpage of the American Society for Civil Engineering. Every few years, they give the United States, on a state-by-state basis, grades for each of their major types of infrastructure. In 2017, the average grade for all of America's infrastructure was a D+. The ASCE defines a grade of D as at poor or at risk. They state the infrastructure is in poor to fair condition and mostly below standard, with many elements approaching the end of service life. A large proportion of the system exhibits significant deterioration. Condition and capacity are of serious concern with strong risk of failure. When discussing water infrastructure, you may hear the terms gray, green, or blue. We have another module devoted to understanding green infrastructure, but we would like to discuss the differences here. Gray infrastructure includes the pipes, pumps, ditches, and detention ponds engineered by people to manage stormwater. Green and blue infrastructure are all the natural and semi-natural landscape elements that form a network. It can refer to landscape elements on various spatial scales, from individual rows of trees or plants to complete forest systems. Examples of green elements include parks, orchards, woodlands, grasslands, and blue elements are typically linked to water. They can be pools, ponds, buffer basins, or watercourses such as streams. The drinking water and wastewater system of the United States is extensive. Drinking water is delivered via 1 million miles of pipes across the country. Many of these pipes were laid in the early to mid-20th century with a predicted lifespan of 75 to 100 years. Though the quality of drinking water in the United States remains high, legacy and emerging contaminants such as metals require close attention. The nation's almost 15,000 wastewater treatment plants are the basic and critical infrastructure for protecting public health and environment. Years of treatment plant upgrades and more stringent federal and state regulations have significantly reduced untreated releases and improved water quality nationwide, but all are at risk due to aging and obsolete water infrastructure. While water consumption per capita is down, there's still an estimated 240,000 water main breaks per year in the U.S., and this wastes trillions of gallons of treated drinking water. According to the American Water Works Association, an estimated $1 trillion is necessary to maintain and expand service to meet the demand that we have in the U.S. over the next 25 years. From a wastewater perspective, it's expected that about 56 million new users will be connected to centralized treatment systems or sewage systems over the next 2 decades, and this will require almost $300 billion to meet current and future demands. New methods and technologies that are turning waste into energy are relying on the nation's approximately 1,200 biogas plants to help communities better manage waste streams through use. Funding water system improvements is a challenge faced by communities throughout the United States. Here, the American Society of Civil Engineering highlights the difference between the available federal funding and the likely funding required to support and enhance the American water infrastructure. They argue that three primary solutions may generate the type of funding needed to address these issues: reinvigorating the state revolving loan fund program, fully funding the Water Infrastructure Finance and Innovation Act at its authorized level, and preserving tax-exempt municipal bond financing are all ideas they suggest to meet these financial requirements. Funding water infrastructure has been a long-term problem faced by states and communities throughout the U.S. In this figure, you can see that the proportion of funding derived from state and municipal governments is getting much, much larger as we move through time. This suggests that local communities are going to be responsible for bearing the brunt of the needed investment in U.S. water infrastructure. Obsolete infrastructure is a big problem in the United States, and here we would like to discuss one particular problem that's facing many communities, and that's combined sewers. Combined sewer systems, as defined by the EPA, are sewers that are designed to collect rainwater runoff, domestic sewage, and industrial waste in the same pipe. Most of the time, combined sewer systems transport all of their wastewater to a sewage treatment plant, where it is treated and then discharged into a water body. However, during periods of heavy rainfall or snowmelt, the wastewater volume in a combined sewer system can exceed the capacity of a sewer system or treatment plant. For this reason, combined sewer systems are designed to overflow occasionally and discharge excess wastewater directly into nearby streams, rivers, or other water bodies. These overflows, called combined sewer overflows or CSOs, contain not only stormwater but untreated human and industrial waste, toxic materials, and debris. They are a major water pollution concern for the approximately 770 cities in the U.S. that have combined sewer systems. CSOs may be thought to be a type of urban wet weather discharge. This means that, like sanitary sewer overflows and stormwater discharges, they are discharges from a municipality's wastewater conveyance infrastructure that are caused by precipitation events such as rainfall or heavy snowmelt.